Hello, hello, hello. Today we will talk about homogeneous production function. Homogeneous production function helps us to identify whether there are increasing returns to scale or not. It has an output Q, which is quantity, and uses inputs that are used in production to produce that output, such as land, machinery, labor, capital, etc. For simplicity purposes, we will focus only on two inputs that are labor L and capital K. Yes, capital is denoted as K in economics. So, we have function Q is equal to a function with inputs L and K. Let's say, for example, we have Q is equal to K squared times square root of L to the power of 3, which is equal to K squared times L to the power of 1.5. To apply homogeneity to a function, we apply Greek letter lambda to each of the input as we see them. We denote Q with asterisk to denote that we are applying homogeneity. So we have lambda squared times K squared times lambda to the power of 1.5 times L to the power of 1.5, which is equal to lambda to the power of 2 plus 1.5 times K squared times L to the power of 1.5, which is equal to lambda to the power of 3.5 times Q, which is our initial function. So we have lambda to the power of 3.5, then we can identify our degree of homogeneity, which is denoted as DOH, and that is 3.5, which is basically power of lambda. In general, when degree of homogeneity is greater than 1, that means there are increasing returns to scale. And in our example, we have our degree of homogeneity of 3.5. So we can test how much our output will increase when we increase our capital and labor. So let's say we increase our capital and labor by 10%. That means we are increasing lambda by 10%, and that will be equal to 1.10. And then we apply our degree of homogeneity, which would be 1.10 to the power of 3.5, which is equal to 1.396, and that means that our output will increase by 39.6% when we scale up our labor and capital by 10%. If you have any questions, please leave them in the comment section. We will try to answer them all. Thank you.